So today we're going to be talking about similarity in right triangles. In order to do that, we're going to talk about extremes and means first. We've done extremes and means before as far as the vocab. Now we're going to show you how it shows up in a geometric mean. This is that proportion that we talked about before. Extremes go first and last. This is spot 1. This is spot 4. It's important to know the difference between the two. This spot's the first spot. This spot's the last spot. For these two, this is going to be spot 2, and this is going to be spot 3. So when you have the two means, this number is going to be the number 1 spot. This is going to be the number 4 spot. Matters. You got to know those spots. So when you have extremes and means set up in their little proportion that we talked about before, when the means are equal to each other, guys, when these two things are equal, they are called the geometric means. This happens in very specific geometric shapes. In a right triangle, for example, you have geometric means. There are 3 of them in every right triangle, and we are going to use those every time when we do those right triangles. We'll show you all our problems today are based on that. But before we get to the pictures, we want to show you the basic idea behind a geometric mean. In order to find a geometric mean, meaning we don't know it right now, what do we put when we don't know something? A variable, x, any variable you want. You're going to set up a proportion. You do not know the geometric mean. These two have to be the exact same thing to be a geometric mean. So if the geometric mean is x, then both of these spots are going to be x. Then the extremes, the first and last numbers, are just going to be these two numbers, guys. This is going to come first at 6. This is going to come second at 15. How do we solve any proportion? Cross multiply. So that's going to be x times x is x squared. And 6 times 15 is what? Y'all have calculators, do it. 90. Okay. To undo a square, what is the opposite of a square? Square root. So we need to square root both sides. And just like we did on the last one, we're going to stay consistent in our rounding. And we are going to round to the nearest tenth. Round to the nearest tenth. What was it? I'm sorry. 9.5. Do y'all agree? Okay. Good deal. There we go. So every single time they ask you to find the geometric mean, this is how you're going to set it up. You're going to set up a proportion. You're going to put an unknown in those two spots. You're going to put the extremes in the first and the last spots. Every time. They're really repetitive problems, guys. They do the same thing every time. It makes them easy if you follow the pattern. So it's going to be x squared is equal to what's 4 times 18? 72. And the square root of 72 is what? 8.5. 8.5? Okay, perfect. Okay. Now, why is the next one different? Read the question. See why it's different. What makes this one different?
We're trying to find what the other number is for the geometric mean.
So we already have the geometric mean. What's the geometric mean?
36.
That's the one that repeats. Guys, whatever is the geometric mean, it repeats in these two spots every time. And it's always got to be the same. Always got to be the same. And then the extremes are going to be this and whatever this is. We've got 12. What do we put for the other one?
X.
X. Good. So that's going to be 12x is equal to a very large number that you're going to tell me. 972?
1296.
Oh, very different. 1296. Okay. Divide by 12. Did you get it that time? Divide by 12. And, oh, did you add them instead of multiplying? Divide that. What do you get? 108?
Yeah.
Okay. So 36 is the geometric mean between 12 and 108. Alright. Anybody have any questions just on the basic idea? That's going to be like your problems all the way up through problem number 14. The entire front of your worksheet is based on that concept. I think problems 9 through 14 are all exactly that kind of problem. The first part's naming them. That's what we're about to do. Okay, I'll be honest with you. These next ones are actually harder for most people than doing the math that we're going to do at the end. I don't know why, but naming these seems to be challenging for some people. So please listen to me when I talk about these. Okay, you have a right triangle. anytime you have a right triangle and you're trying to deal with geometric means, you need to put the big right angle, the one for the whole shape, at the top. Listen to me. Your pictures on this worksheet are not going to be all like this, where that big N is at the top. You're going to have to turn your paper until that big N, until that right angle is going to be at the very top. Turn it till, see this one, you got the right angle at the top. You always want your right angle, the big right angle, the one for the big shape, at the top. Once you do that, it's going to have an altitude in it. That altitude, which, remember, an altitude starts at one of the points, one of the vertexes, goes the opposite side at a right angle. That line is going to create two more triangles. Do you see the small triangle on the right and the medium-sized triangle on the left? All three of these triangles, the big one to start, the one on the left, and the one on the right, are all similar to each other, meaning they have all the same angles. They're just going to be proportional to each other. They're not the same size, but they're proportional to each other. We're going to need to name them. Name them. So to name these triangles, the easiest way to do it is to name the first one on the outside in a certain order and stay in that order. So I'm going to name this first one by starting at the end of this at E. I'm going to go up to D, and then I'm going to go down to A. Okay, so I'm going to go E, D, A. Now let me talk about what I just did. I started at the end of the short leg. I started up here at the end of the short leg. I went to the right angle and then down the long leg. Okay, so if I am looking at that medium-sized triangle, where is the end of, well, first of all, which is the short leg, DH or AH? DH. Which is the end of that short leg that is away from the right angle right there? D. So I'm going to go D. I'm going to go down my short leg and go to H. So I'm going to go D, H, and then A. D, H, A. Okay, now the other triangle is going to be the one that's on the right. It is the smallest of the three similar triangles. I need the short leg of that. Which side is the short leg of this triangle that is over here on the right side? EH. So I need to start at the end of that short leg, so that's going to be at E. I'm going to go E, down to H at the right angle, and then to D down the long side. So that's going to be triangle E, H, D. Guys, do you see you just need to follow a pattern? Does your angle, do these have to be the same as mine? Yes or no? No, because whatever pattern you established at the beginning, if you went ADE, if I could write, hold on. If you went ADE, then for this one you'd have to go AHD, and then you'd have to go DHE. They just need to match, guys. It doesn't have to be the same as mine, but whatever you establish here at the beginning, you have to follow the same pattern for all three of them. Okay? Does anybody have any general questions about the idea? There's three similar triangles. That's it. Three similar. Wherever you start, just go like short leg, long leg, or hypotenuse, long, whatever you do, you just got to do the same thing. Okay, now let's talk about the real actual like problems that you're going to be doing with the most math in it. These are the algebra-based problems. They're going to come from these relationships. Listen to me. How I told you that big idea of the right angle at the big right angle floating at the top, that's a big deal. Because these relationships are forming geometric means. The ones right now that are floating in the air, these three are always going to be your geometric means. These are the ones that are going to repeat every time. These three, the floaters are the repeaters. The floaters will repeat. Okay? The ones at the bottom are going to be the extremes. These right here. This A, this F, which guys, look at F. F is just a combination of what two pieces? A and C being added together. That's all it is. And then see, these ones down here at the bottom are all going to be your extremes. Okay. Those are going to be your first and last one. Okay, I'm going to do this by colors. Tell me if you have a question or concern as we go through. I'm going to start with the green for the one in the middle. The one in the middle is the easiest one to do. This one right here. This is the geometric mean, so it repeats here and here. B and B. It is the geometric mean between the two pieces of this line that are at the bottom that it connects to. What are these two pieces? What and what? A and C. That's it. There's your relationship. B is the geometric mean between A and C. Okay. Now, I'll do purple for this one. This one over here on this side, D, is a geometric mean, so D is going to repeat. D goes here, D goes here. It repeats. What does it touch down there on the bottom? Okay, it touches A, but it also touches F. So it is going to go between the A right here, this piece that it touches directly, and then the whole thing. The ones on the outside always use the whole thing, guys. It gets confusing for some people. You're going to have to understand that it connects to the A, and then the whole thing is the other piece of it. So A and F. It's one of those things you just got to learn. Now, I'll go over to blue for this other side. This one right here, E. E is the geometric mean because it's floating, so it's the one that's going to repeat. And it repeats between the ones that it touches. What does it touch? C and F. It goes between C and F. Now, personally, I do better when it's an actual picture with numbers and everything else. Some people see it better just in all variables, but we're going to go ahead and do some problems. Maybe it'll connect some things for some people. But these are the three formulas, guys. That's it. Any questions just on the formulas? Yes, please.
So this is universal?
Yes, on any right triangle. It works on any right triangle. Anybody else? Good. Okay, I know I'm taking a little slow, guys, but I just want to make sure you get this. I want to make sure everybody gets it down. Oh, wait, was anybody still writing? No? Okay, here we go. Here's our first problems. We're going to start with E4. It's over here on the right because it's the one in the middle. The one in the middle is always the easiest one to find. That W is your geometric mean because it's floating in the air. So W repeats. The repeats are always floating. And what's it going to be between? What and what? 6 and 4. It's always between the two pieces that it touches down on the hypotenuse. So to solve that, that would be W squared equals 24. To undo a square, you would take the square root of both sides. And what's the square root of 24? It's got to be close to 5. 4.9. Thank you. Perfect. Okay. So for this next one, before you do anything, do you see how you've got an outside piece? If you have an outside piece, guys, you're going to need the entire piece all the way across the bottom. So go ahead and draw that line. As soon as you see one on the outside, draw the line all the way across. How long is the whole thing? 10, because you add the 6 and the 4. All I'm doing is 6 plus 4, and that's going to give me 10 right here. So now when I do my geometric mean problem and I set up my proportion, what repeats? What repeats? X. He would give me the next thing. Answer the question, but the wrong question. And it's going to between what and what? White. 6 and 4 would be for the one in the middle. For the ones on the outside, it's going to be the 4 that touches it and the 10. The ones on the outside always use the whole thing, so it's going to be between the 4 and the 10. So it's going to be x squared equals 40. And then what's the square root of 40, guys? What was, I'm sorry? 6.3. There we go. Okay, again on this next one, do you see the y is on the outside? If the y is on the outside, go ahead and draw that line. You need the whole thing, which the whole thing, again, it's the same picture every time if you haven't figured that out, guys. It's just a different piece. You know, the whole thing right here is just 10 because you're adding 6 and 4. That gives you a total length of 10. So your y is going to repeat. Because it's the floater, it's the one that repeats. And it's going between what two numbers?
16.
Yeah, you got it. So it's going to be y squared equals 60. Take the square root, and y equals 7 point what, I'm sorry? 7, perfect, 7.7. There you go. Alright. Anybody have any questions? Those are the basic problems. Those are going to be like problem numbers, well, here, all the geometry ones, 19 through 22, you'll have to solve like that. No? Okay. Anybody still ready? Okay. Last ones then today. These are going to be the ones where they have more than one variable on them. You have to decide which one to do first. Guys, first things first, you're going to look for where the numbers are. If you've got numbers, then you can find other numbers. If you have all variables, you can't find other numbers. So we're going to look where there is a floater that has a number. That usually is one that's going to be easy to use. I've got this 18. That 18 would repeat between the one that touches it, which is W, and the whole thing, which is 36. Okay. We're going to solve this, and we're going to use this answer to find the other answers. So you got to work this one out first. That's going to be 36W equals, what's 18 times 18? 324? Okay. Divide by 36, divide by 36. I hope it divides evenly. To what? 9. Perfect. So this piece right here is going to be 9. Now, guys, I can find y without doing any of this fancy stuff. I can do old stuff.
Subtract 9 from 36.
Yeah, that part plus a part equals a whole idea, guys. I've got the whole thing. I've got this little piece of it.
It's 27.
Now I got to find this other piece. So I do that 36 and just subtract my 9.
It's 27.
Should be 27. Good. Now, guys, listen to me. Is that thing drawn to scale? Do they have to be? Not in geometry. Unless they tell you it's drawn to scale. That bothers me, personally. I don't like when things don't look like their numbers should say. I mean, like they say they should, but it doesn't. But you just have to accept that. Now we can do the other side, because now we have the W, we have the Y. Now we need to find the X. For the X, I'll change colors. This X out here, this piece right here, is going to be between, it's going to be repeated, because it's a floater, and it's going to be between the one that touches it, which is 27, and the whole thing, which is at 36.
Equals 900.
Hold on, I can't write that fast. X squared equals 900 and what?
72.
72? I'm just slower than you. So divide, or excuse me, take the square root, take the square root. Is it a perfect square? No. Okay, what's a decimal? 10 what?
31.1.
31.1?
Wait, no, it would be 31.2.
Oh, it would be? Does it round it up? What's after the 1? 7, yeah, it does go up to 2. Good. 31.2. Good. Okay, guys, so what I need you to do is try to solve the next one and try to get these. I need to see if you can ask me questions about it, see what it is that you need to get. So, just out of curiosity, which one of the floaters would you do first?
12.
The 12. Do the one with the number first. It'll help you find the other variables, and then you can build from there. Okay, start with the 12. Let's see what this email is. Okay, check your first one if you got it done. See if you got that first one right. I got 6 for W.
Same.
Just look and see. Does anybody have a question about how I did W? Anything about that one? That's not what we do. Come on. So what do you do after that?
I do 5.
You can do either one, but you
Oh,
gotta
you
combine
gotta
these
add
first.
things.
You gotta add these first and get the length of the whole thing before you can do X or Y. Then you can do either one of those. It doesn't matter which one you set up. The ones that float are gonna repeat, so the Y is gonna repeat, and the Y repeats between 24 and 30. The X is gonna repeat, and the X is gonna repeat between 6 and 30. The outside ones are always going to repeat between whichever one touches it and the whole thing. So this number should be the same on the outside ones. So y squared equals 720. Y squared equals 180. Square root, square root, square root, square root. Oh, I know. Meg see things before I do. It irritates me. Not in a bad way. Okay. What's the square root of 720, guys? 26.8. Okay, and what's the square root of 180?
13.2.
13.4.
4. Wait, which
Got
one?
different numbers?
I misread that.
I got 13.4 on my key. Just I'm looking at it. I think that's what it says. Yeah.
Yeah, I
You
looked
good
at
on
my
that?
calculator, I just misread
Okay.
the numbers.
So you're good?
Yeah.
Okay. Anybody have any questions on this set of notes? Okay. So, due to time, I think I'm gonna just do evens on the homework. That's what I think I did. I can't remember which. I don't care. We'll do evens in here. I think I'm gonna do even on the homework. That should be enough. We have another. If I had only one day on this, I'd probably make you do the whole thing. But because we have another day on this, let's just do evens on our homework today. Okay. So what I need you to do though is I need you to open up your folders to your assignment sheet and write evens on there right now. So your assignment sheets are correct. Add evens to the assignment. We're only gonna do the evens. So pencil over on it for a while. Do what?
I still need
I gave him two. It was lost. It was just me fixing it. That's what I messed up.
Oh, what was the, camping,
Oh,
this
I
next
have
semester?
it here. I'm thinking that's, I would love to just put up there. My daughter went to visit ASU one time, but that's the farthest we got, was just seeing the college, the law school. But I've never been to Arizona. I've been to like Las Vegas and Nevada and some other places, but never to there. Okay, the lady lives next to us, lives in Arizona. Okay, guys, put your name, date, period, and assignment number 2. Name, date, period, assignment number 2. What's the first thing you ought to do right now? Cross out the odds. Go through and cross out the odds right now. Right this minute. Go through, because if you're like me, you guys mess up. Yes, ma'am. Yeah, absolutely. You know the filler's right there. That one. Yeah. Alright, try some. Let me know if you have questions. He's up here. I'm up here. Just get your work done, guys. Come on.